All right, Zara. So in the last class, Zara, we started with the topic power. And let me just give you a quick brusher of the power that we have discussed. And if there's any specific trouble, you can ask. Zara, is the problem of assignment resolved?
I still can't upload it, ma'am, because the app is not available on iOS and I don't have an Android device. So you
So
need
what
the app
about
to upload the
laptop?
picture.
Do you have any
I
laptop?
still did not get my laptop. I'm still using my phone. I did ask the people if I can send it on WhatsApp and then they said no, ma'am.
You have done the assignment, Zara?
Yes, ma'am, I have.
Wait then, wait, let me talk. Otherwise, if the chapter is about to end today. Okay,
You
after a
want I the
yeah.
pictures on WhatsApp now?
No, let me just talk because this should be fixed. How much trouble you should face? No, let me
Yes.
discuss. Let us discuss this first. See, we started with the topic power in the last class. Basically, we discussed that power is the rate of doing work. Rate means something that is changing with respect to time. A specific change with respect to time. So power is equal to work done by time. Now work done is in the form of different kinds of energies. Work is in the form of potential energy. Work done is there in the form of kinetic energy. So all these energies can be utilized in place of work done, and you can get your definition of power. Okay, power is equal to work done by time. And SI unit is joules per second. That is watt. So joules per second we do not use. We directly use the unit as watt. It's a scalar quantity. And average power and instantaneous power. Yeah, I was telling you the differences about these. Average power is basically when you have a specific duration given to you. If a duration is given where you have to calculate the final minus initial, you should definitely go for the average power. And when the time duration is present, like 4 to 10 seconds, 8 to 10 seconds, 8 to 12 seconds, like this. Then instantaneous power means time instant is present, like at t is equal to 4 seconds, at t is equal to 2 seconds, like this. So this is what we discussed. One small but important derivation I have to discuss with you that plays a significant role. See, power is work done divided by time. All right. Now, when we write the formula of work done, that is force into displacement. So if I put it here, power will be actually power is in fact dw over dt, rate of change of work done. No? So it means I'll have to put d over dt, means I'll have to put the value of f dot s here in place of work done. I can put f dot s. Now, if your force is constant, there is a constraint here that if the force is constant, when we differentiate, the constant term comes out and the rest of the terms left over. Azara, I think you mentioned once, no? You want a class of differentiation and integration, no?
Yes, ma'am, because on Sunday I have my midterm paper.
When? This Sunday?
Yes, no, it's basically just a small formality. I just have to pass the exam. The passing mark is 23, so that's it.
Okay, but what kind of exam is this?
Because I did tell you that I was repeating my 11th with science now. So
Yeah,
that
yeah.
time I missed all of my midterms. So
Oh,
now that school has reopened, they want me to write all of the midterms and they just want me to pass the exam.
all right. Zara, you were initially you have opted for commerce,
Yes, I did complete a year with commerce. I had also started my 12th with commerce and then I
but
went
then
for career counseling. So I had changed
you
it.
switched to science. So now are you comfortable and are you happy, satisfied?
Yes, ma'am.
So what are you aiming then?
Most probably engineering, ma'am.
Engineering. Okay, so
Or,
PCM.
or architecture.
Oh,
Yes.
so from India. Are you from India?
Yes, ma'am.
So from India only are you planning?
No, I am also planning from Saudi as well. I'm gonna write a few exams here as well or Georgia.
Okay. All right. So see, I was saying ds over dt is the speed velocity. So power is equal to force into velocity. Zara, on Sunday you have this.
Yes. I did
Sunday.
text them last week, ma'am. I texted I think on Thursday.
Okay, you have texted them. You have texted.
Yes, and they later told me that they have two different numbers for different things. One is
Okay.
for timing and one is for these things. So I did not know that.
Okay. Anyways, I did not receive any message. Otherwise, I would have. I didn't know. I had no idea. I'll just say this also. So 7th was this Sunday. So 14th. 14th we are.
Yes, it's on 14th.
Okay. Never mind. We will complete a major portion of this chapter today itself. And in the next class, whatever is the leftover part, along with the differentiation and integration, because you just need a brush up. No? Something you must have already studied in the school.
Yes,
Or how
because
are you
this
with this?
chapter is not there for the exam, ma'am. This is for PT2. PT2 is
Ah,
starting
yeah.
from
You
20th
mentioned.
September.
So, what all chapters are coming then for this one?
I have the first four chapters:
Total
motion in a
of.
straight line, motion in a plane, laws of motion,
Do you
units
need
and
the playlist
dimensions.
of the batches?
Yes, ma'am, I would prefer that if you could provide it.
Okay. If the I'll share the batch links playlist with you so you can pick up the videos, forward, skip whatever you want to do if a specific topic you want to see. So at least it will give you some basis. Okay, let me just talk to somebody from the team while you copy down this. Okay, just text me you're done when you are completed.
Okay,
Once
I
my
will.
call is over, I'll just talk to you.
Okay, ma'am.
Okay, Zara, see, for the assignment part I have discussed, for the assignment in your iPhone, you can download Chrome, and in the Chrome, the link will be given. So by that, you can open. Okay.
Okay, ma'am.
And for the playlist, they'll be sharing you the playlist shortly. I think within 2 minutes, the playlist will be shared of another batch that is ongoing. So the previous chapters you can see, just see whatever topics you want forward, 2x, make it double speed or whatever you prefer. But even after that, Zara, if you still need any help, because videos are recorded lectures and they are interactive for that batch, for that particular moment. So by seeing some things may skip through you, right? So you please let me know whatever help you want so that we can arrange classes for that also, even for this exam also. And one more thing for your half yearly, Zara, what's the scene of your half yearly right now?
They told me that I have like 5 exams and I just have to pass all of them so they can include it in my internal marking.
No, no, PT2, which one? Which where this work done is coming?
That's my PT2, ma'am. It's an exam for 25 marks.
Okay.
So I have this chapter and one more chapter, and she's not confirming that chapter. She said that she'll see after the practicals because I have practicals this week. She,
Okay.
she's going
Got
very slow with everything. So we'll complete this chapter by Tuesday, and then on Wednesday, Thursday, I have my practical.
it. So right now in the school, chapter fifth is only going on.
Yes, chapter 5.
Okay, then you cannot tell right now because this is only there. Okay, no problem. But next week, just update me whenever you get. Okay. Text them
Okay.
on WhatsApp. They forgot to share it with me. Otherwise, I would have known. Okay. See,
Okay.
within this, let's see. One very easy question let's discuss. Then one conceptual question we'll see. This is a force of 10 Newton acts on the body and it starts moving with a velocity of 5 meter per second. Calculate power. So force is given as 10 Newton. Velocity is given as 5 meter per second. Power is given as force into velocity. Force is 10, velocity is 5, power is 50.
Words.
Yeah. Okay. So just a simple formula based question. This is a little important question because it has a concept that is used in different questions of laws of motion as well. This is a body of mass 100 kg is moving up an inclined plane with a velocity of 10 meter per second. Okay, so this is moving up an inclined plane with a velocity of 10 meter per second with slope 1 and 5. Now see, this slope 1 and 5 basically means sine theta is given as 1 by 5. The value of sine theta is given as 1 by 5. This is often used, and I'll tell you one more thing regarding this later. Let us discuss this first. It is calculate power spent by the energies. See, downwards you have the gravitational force, that is M2. Upwards, perpendicular to the surface, you have the normal reaction. Now, when we resolve it, we have to resolve everything around the inclined plane. Okay, everything around this inclined plane we have to resolve. It's not visible. Okay. Anyways, here across this inclined plane, this we have to resolve. Let's say this angle is theta. This angle will also be theta. Do you know how?
No.
This is theta. This is 90 degree. So this
Oh,
becomes 90 minus theta. So total 90 this theta. Okay.
okay.
So see, when we resolve the vectors, this part will be mg cos
Hmm.
theta or sin theta.
Sine theta.
No, no, no. Theta is adjacent to this axis. So this receives cos theta, okay? And the perpendicular one receives mg sin theta. Wait, let me tell you this. You have a vector and the angle is made here. So this one receives the cos component, vector is cos component, and this receives the sine component. While when you have, let's say, if I change the angle, it's not about x or y axis. If I say the angle is made here, this is my y-axis, so I should get v sine theta. No, it's not related to your axis. This one will be v cos theta and this one will be v sine theta. These are
Sine.
known as rectangular components. Okay.
Okay.
So see, force, now see, normal reaction, this normal reaction will balance the mg cos theta. Now, why? Why can I say this? How can I say this? Reason is that there is no movement along this normal reaction and mg cos theta. Perpendicular to the plane, there is no movement. If normal reaction was not balancing and it was more, body would have moved up. If mg cos theta was more, it would have pulled down. But body is not moving like this. Body is moving like this, up the inclined plane or down the inclined plane. It is not moving like this. So normal reaction is balancing this mg cos theta. So n will balance this mg cos theta. You have a block here, and now the force that will be required here will be this mg cosine theta. This is the leftover force. So this is force is your mg sine theta which is acting. Okay. And velocity is already given as 10 meter per second. Velocity is given as 10 meter per second. And sine theta is 1 by 5. So power is force into velocity. So force is mg sine theta into velocity. So power will be, mass is 100, v is 10 or 9.8. This is 1 by 5. Velocity is 10. So this makes it 2. That is 2000 watt, or even you can say 2 kilo. Is this question clear?
Yes, ma'am.
Okay. Now, one concept that I was trying to tell you was using the slope part, slope 1 and 5 thing. Slope 1 and 5, part 2. Sometimes this is not related to this question, but since the term has come, so I'm discussing. Slope 1 and 5 basically means your sine theta is equal to 1 by 5, whatever is given, slope 1 in 10, 2 in 8, whatever is given. So using this, sometimes you will not require sine theta and it will give you slope 1 and 5. Then what will you do? What it means is, this is sine theta is what? Perpendicular upon hypotenuse.
Yes.
This is basically the perpendicular and this is basically the hypotenuse. Okay,
Hmm.
perpendicular by hypotenuse, that is sine theta. So basically this is that if you have a triangle, the perpendicular, base, hypotenuse. This is theta over here. So
Hmm.
the value of perpendicular is 1, hypotenuse is 5, and using the concept of Pythagoras theorem, you can calculate this base. Base will be under root h square minus p square. So base will be 25 minus 1, that is equal to root 20.
24.
Yes. So it means base is root 24. Now, if I want cos theta is base by hypotenuse. So I can say root 24 divided by 5. If I want to write tan theta, that is perpendicular upon base. That is 1 by root 24. So see, by using this, you can calculate any angle if slope 1 and 5 is given. Clear?
Okay.
Okay, now the last topic, collision, is left. You write it, understand, and if there's any trouble with any of the part, please let me know. And then we'll have a discussion of collision, the new topic. Okay, please write it.
Okay, ma'am. Ma'am, can you scroll it down? A little up, ma'am, so I can see the figure as well. It's fine. Perfect. Done, ma'am. Done, ma'am. Done, ma'am.
Okay, see, let's discuss what is the meaning of the term collision. Collision involves your movement between the bodies and the contact between them. Basically, two bodies are there, and this involves your momentum. This should have been included in your work energy, in your laws of motion, but since it involves the conservation of energies, that's why it is given at the end of work energy and power. So it's like a portion from your laws of motion also and work energy and power. So collision means, see, there are three events that occur. First is the event before collision. Means two bodies are moving. This is first body with the mass m1, its initial speed u1. Second body is there with the mass m2, its speed u2. And they are moving with their own velocities. Now, then is the second part, that is during the collision, which is your actual event. This is your real event that occurs. This is the initial scenario. This one is the initial scene. Now, during collision, what happens? Both the bodies, they come in physical contact with each other. They actually collide with each other. That's what is known as collision. So during collision, both the bodies are present. M1 is there, M2 is there. They are exerting forces on each other which are equal. Now, why these forces are being exerted? Because of Newton's third law of motion. To every action, there will be equal and opposite reaction to it. But the net force of the system is zero because there is no external force acting. So this is an isolated event that occurs. See, since the net force is zero, we call this as an isolated event. Isolated system means the net force is zero. During this moment, entire system will act as one single system. Then what happens? This is the third part, that the bodies, they separate from each other. Body M1 is there, M2 is there, they have their own velocities V1, V2, and they get separated. So bodies, they are moving with their own final velocities, and they are. So what exactly is collision? Collision is an isolated event in which a force acts on the body for a short duration of time. Now, whenever forces act for a short duration of time, we call those forces as impulsive forces or impulse. That's why I'm saying collision is a topic from a little bit of your laws of motion and your work energy and power. Both the things should be combined. So impulse is what? Impulse is the force that acts for a very short interval of time. Like if I say, let's say, ball is coming and it has hit the bat. So when the bat and the ball are in contact with each other, that force is very strong. But that contact is for such a short duration of time because ball immediately goes away. There is no, even I don't think so, even 1 second is completed. So that for fraction of seconds when a force is applied, a great amount of force or a lesser amount of force, but for a very short period of time, that is called as impulse. So which results in change in their velocity. So collision is an isolated event in which large force acts on the body for a short duration of time. It means impulsive forces which result in the changes in their velocity. Physical contact is not necessary. See, physical contact is not necessary means initially. Even if the bodies are far away from each other, one can overtake the other one and then they can collide. Here, they'll definitely be in contact with each other.
How is it possible without physical contact, ma'am?
If two bodies are moving like this, before collision occurs, it's not necessary these two are stuck together and they are moving like this. They
Oh,
can move.
but the
Okay, but
process physical
yes,
contact is necessary.
process is definitely, but without process, collision term is on will not only exist. Okay, so that you're right. And see, there are different kinds of collisions. You have elastic, and in this I'll come later. First, you write down this introductory part, then I'll tell you about the types of collisions.
Okay, ma'am. Ma'am, can you scroll it down? Done, ma'am.
Okay, see the types of collision. You have elastic and inelastic. Now, in both of them, one dimension is there, two dimension is there. One dimension means both the bodies are either colliding from opposite ends or they are colliding like this, another one is overtaking, but in one line only, in a straight line. 2D means both the bodies are colliding either from opposite direction or from the same direction, but once collided, the other body moves in a random angle in 2D in a plane. So this occurs in both elastic and inelastic. But what are these elastic or inelastic? See, these types of collisions are basically put on the basis of the conservation, whether they are able to conserve the total energy or not. First point is very simple, that elastic collision is based on the conservative forces, while inelastic is based on the non-conservative forces. Remember we discussed about conservative and non-conservative forces.
Yes,
Work done,
ma'am.
yeah, initial and final point and on the entire one, on the entire path, so the same one. Second is there is no loss of energy. Because this depends on the non-conservative forces, there will be some loss in the form of energy and heat. Now, the main point. This is actually helpful. The rest of it are there for your writing part in the exam because this difference sometimes comes in the exam. This one is important. Here, both momentum and kinetic energy are conserved. P means momentum. Momentum and kinetic energy are conserved. Here, momentum remains conserved, but kinetic energy is not conserved. Okay, kinetic energy is not conserved. Here, internal force acts and kinetic energy is not conserved. So, as a result, total energy remains conserved because kinetic is already conserved, potential was already conserved, so total is already conserved. But here, since kinetic energy is not conserved, means initial is not equal to final kinetic energy, total energy is also not conserved. Total energy
Is
is
also.
not conserved. Yes. So Zara, just make a tabular form of it and write it little in a neat manner, not like this, because sometimes this question comes. Okay, write
Okay, I
it.
will.
Then I'll start with elastic collision first. Elastic is the most important one. Okay.
Okay. Ma'am, can you scroll this down? Done, ma'am. Done, ma'am.
Okay. Now see, Zara, there's a concept of coefficient of restitution. This coefficient of restitution is basically a constant term which with which see energy conservation identification is difficult in the numericals, right? If you have the energy in, see, if you have the application based question, then you will be able to identify some things. But for the numericals, by just seeing the kinetic energy is getting conserved or not, it will be very difficult for you to identify, because every time the kinetic energy getting conserved, energy is getting conserved is not a visible thing. So for that purpose, a coefficient of restitution has been designed that just gives you the exact values of elastic collision, inelastic collision and all. So this is just a constant term. It does not have any physical meaning. It's just for the calculation purpose. Physical meaning is that energies are conserved or energies are not conserved. Now value of this coefficient of restitution is equal to 1 for elastic collision. It is less than 1 for inelastic collision and 0 for perfectly inelastic. Now, what is perfectly inelastic? Two bodies were moving, they collided. Now, they remained collided. Okay, they didn't separate. So, when the bodies are collided, now they are behaving like one single body with one single velocity. So bodies basically stick to each other. That is what is meant by perfectly inelastic. That's one specific case. In that case, E is 0. So these three values should be remembered by you. E is equal to 1, E less than 1, E 0. Because for numericals, sometimes the questions will not state whether you have to choose it, which condition you have to choose, elastic, inelastic and all. So what you can do, you can simply see if the value of coefficient of restitution is given or not. Now, what is this coefficient of restitution? See, this is the case before collision. U1 is there, U2 is there. U1 is the velocity of the body M1 and U2 is the velocity of the body M2 before collision. Then during collision and then after. So see, if this is the case when U1 is moving and U2 is ahead. So if U1 is less, it will never be able to overtake this and collide. What will happen? U1 will always lag behind, this will keep on moving. This will be the scenario. So U1 has to be greater than U2. So when you calculate the relative velocity means, see, the velocities with respect to each other. So relative velocity of approach means here the relative velocity between them means the initial velocities between them. That will be u1 minus u2. This will be u1 minus u2 because u1 is greater in this case. Usually we have final minus initial, but u1 has to be greater in this case. Otherwise, how will the bodies collide each other? Now, afterwards, we will use our usual formula, that is V2 minus V1, the usual formula for the relative velocity that we calculate. So this velocity U1 minus U2 initially, because it's in the initial scenario, this is known as the relative velocity of approach. And finally, when the bodies get separated, this is known as the relative velocity of separation. So what is coefficient of restitution? It's the ratio of these things of V2 by V2 thing and U1 thing means coefficient of a ratio of the velocities of separation V2 minus V1 by the velocities of approach U1 minus U. This is known as the coefficient of restitution. This is how it is calculated. And why E is equal to 1 in elastic collision, that derivation comes in your exam also because it's there in your NCERT listed and it's a part of your syllabus. But till here, have you understood this part?
Yes, ma'am.
Okay, this is what this part is the separation one. This is the separation one, while this is the
So the final velocity will be separation and the initial will be the
approach. Yes, because they
approach.
are approaching to collide, and after collision, they are getting separated. Fine.
Okay.
Okay, please write it from here.
Okay. Ma'am, can you scroll it down? Done, ma'am. Done.
Zara completed.
Yes.
Okay, Zara. So I'll stop here because the next
Ye-
topic will take a time, and I think you have your chemistry class also, no?
yes.
Okay. All right, Zara. So let me stop you. In the next class, let's meet then. Okay.
Okay, ma'am.
All
Ma'am,
right.
can you also tell me the important topics from the first four chapters which you are quite sure will appear in the midterm?
First four chapters. Okay, I'll just share a list with you on WhatsApp. Okay.
Okay, ma'am.
When is the exam, Zara? 14th, Sunday.
Yes. It's
Okay.
from I have 5 exams all together in 1 week.
Oh, so will you be able to take classes the next week then? This week?
I, ma'am, next week, right? But I can manage because